Oh, yes.
Oh, now that sounds like a terrible idea. Just putting that
Yeah.
out there.
It should have been that should have been lesson number 1, not lesson
It
number
should have been
6.
really. By
Um,
this stage, everyone is completely screwed.
yeah.
So, Kev, I thought we'd do something a little bit different today. To what we
How
normally do.
exciting.
I know, just to mix it up a bit. You wrote something really interesting. I don't mean to sound surprised, but you wrote something really interesting, which I thought, for those who couldn't be bothered to read it, um, others might find it interesting as well. So I think there's a good story here, both in terms of what's going on with people like yourself, engineers who over time elevate themselves to the stratosphere of business life, and and also what's going on in the industry at large with the arrival of new tooling, new processes, and indeed how we approach software engineering in general. Um, Kev, give us 30 seconds. Why is it you don't build stuff anymore?
I don't build stuff anymore. I am very time poor, I think. And once you've done all the things that you need to do in the constant juggling of running a business, the last thing you want to sit down and do is like bash out code or read through complicated API specs or docs. So, much as I guess at one point in my life, I enjoyed coding and I was reasonably good at it. Since taking on running a business, I think it's become almost impossible. It's certainly something I don't really want to do at the end of the day or in my spare time.
So why did you build this? What is this? What are we talking about? What happened here?
Well, obviously the whole industry is going through a whole load of change at the moment, and agentic coding tools have come onto the scene, and everybody's figuring out how to rewrite their life around this. And the whole kind of software engineering field is changing. What it means to develop software is changing, and so we've been all over that. One of the tools that came out in the last few weeks was the Codex Mac app. Codex was an agentic coding tool that already existed. The Mac app kind of elevated it, I suppose, to a different level of abstraction. And
Just for people that don't know, what is an agentic coding tool? What are we talking about here specifically? This is you're not just talking about a copilot assistant type thing. What is an agentic coding tool?
yeah, so I guess this is like moving from somewhere where maybe the AI might help you write code a little bit or suggest some stuff. And mainly you're copy and pasting and reviewing. So it's kind of like a better autocomplete, I suppose. That was kind of where we started maybe a year and a half ago. We've moved on since then, and now these agentic coding tools are essentially like having a software engineer or maybe even a software engineering team at your disposal. So you're not writing the code anymore. You're steering how that code is written. You're having discussions around planning and architecture. You're figuring out how the things should hang together, and then you're kind of telling this clever software I say software engineer, but that's what we are, isn't it? So this is agentic engineer to go off and do it, and they do, and then they write the code and they write all the tests,
Okay,
and they deploy it all, and there you go.
can hear the alarm bells ringing everywhere. Every software engineer that's listening to this, or every senior engineer that's listening to this, is thinking, "Well, this stuff doesn't work. It's not real. I've had a go at some of these vibe tools. What are you talking about? This sounds terrifying." So why don't you just maybe go into a little bit more detail about the approach you took on this this challenge that you undertook? What was the challenge?
Yeah, well, I wanted to basically. I mean, look, there's a whole bunch of people in our business that are already flying with this, but I wanted to make sure that I really understood it, and this was my chance to take it for a spin. So I wanted to test the bounds. I still am testing the bounds of what it's really good at, where it still falls down. What does it really mean for the future of software engineering? Outside of all the hype. So the little project that I decided to try on was essentially a smart thermostat app. Okay, so I have a Google Nest. They seem to be slowly pulling out of the UK market, and if you're on these older models, all the smart stuff is just dying off. and you can only kind of just sort of set a scheduler. And I've always been frustrated with the amount of data and access to the data that these things provide. They don't let me go deep enough. They don't let me explore the things I want to explore. It's pretty nerdy, but it gave me a good excuse to try and build something. So this was basically a replacement for a smart thermostat app, but that did everything. So it collected all the telemetry, it did all the machine learning and the modeling. It figured out, how fast your house was warming up and how fast it was cooling down. I wanted to make sure that it could do some profiling around the weather. So, how much additional heating was I getting for free when it was sunny? How fast was the house leaking heat when it was cold or rainy? I wanted to own my own data and be able to interrogate my own data and kind of go back through history and figure out a load of thermal insights, I
This
guess,
doesn't
which is
sound
what.
like a small undertaking, right? This does not sound like your standard hello world stroke to do app, to kind of prove a new tooling or play a new language. This sounds monstrous. I mean,
Yeah. Well, you know where it starts. You go, oh, maybe it'd be good if I could just set the temperature, and then you kind of go from there. And I was quite surprised where we started. I would, if it would be me, I wouldn't have started where we started. But quite quickly with Codex, I got to the point where we'd created an app and a kind of monstrous back end that did have a whole machine learning model in there, and that was basically created off the bat. So we did an initial planning session, and then it went away for an hour, and this thing existed.
just back. We did an initial planning session. Just again, what do you mean there? You and your buddy, or
Me
what?
and my
What?
buddy Codex, yeah. So they, these coding tools, they always suggest that you start in plan mode. A lot of the pros, if you can call them pros, I mean, people only be doing this for a few months. Um, they don't tend to use planning mode. They just go in straight in and have a conversation. But the point is, the mental mode you put yourself in, or the physical mode in the tool depends. Is right. We're going to figure out what we're going to do. And then we're going to figure out the approach to that, how we're going to do it. We're going to explore what the edge cases are. We're going to make sure we've covered off all the kind of detail that we need to cover off, and really, really lock that plan in place before you then go off and hit go. And that's when the agent goes off and starts building all the code to the pre-agreed spec that you've been working on.
Okay, so give me a sense of scale here in terms of what was built. What was the output? Have you got an idea of kind of the amount of lines of code, or number of functions, or the what came out of this thing?
I mean, it's tens of thousands of lines of code. I've been working on this for a week and a half now, I suppose, so it has grown a lot. So I don't know how much was in the initial cut, but it was substantial. Very quickly as well, I needed to keep this running 24/7, so it needed to be hosted somewhere. And so because I was like, well, let's do this properly. Let's host it on Google Cloud Platform. Let's make the whole design serverless, so it's elastic and scalable, and it's it's architected really well. And because Codec could, we developed a whole bunch of infrastructure as code, which is basically a whole bunch more code, which tells the cloud provider, whether that's Google or Amazon or AWS, how to spin up all these resources in the cloud and then deploy them. So this app automatically deploys itself to Google Cloud Platform, spins up all the different services it needs, and uses this kind of nice sort of enterprisey architecture.
So you're a self-declared non-builder.
I'm a
You're
non-builder.
architecturally aware, I think, but you probably wouldn't declare yourself chief architect material these days because the
Bit
world of
rusty, yeah.
you're a bit rusty, but you're architecturally aware, and you've moved onto one of these agentic platforms. Codex was your flavor of choice today, and you've managed to build something incredibly complex, incredibly quickly. If you're not a builder, what does that make you in that instance?
I think the word that is used, whether it's a good word or the right word, I don't know, but would be an orchestrator, I guess. So I know enough to challenge the stuff that comes back from the agent. I know enough to push the boundaries of what it wants to create in the first place. But really, I'm directing it to build this thing for me. So, yeah, I'm not writing code, but I am building the system. I am thinking about the system and defining the system and orchestrating the agent or agents to go off and build this thing.
So do you think you could have built this if you had not been architecturally aware? If you'd just been, I was gonna say just, don't mean to be condescending. If you'd been a product owner or a project manager or a business analyst, someone who knew that you wanted to build an app that did the things that you wanted to do, would you have been able to make this thing so that it was ready, deployable, safe, secure, ready to go?
This is quite an interesting question. I probably want to try and unpack this over kind of several rounds. So, um, so if you were completely green, you could have built the first version of this app, not knowing anything, including the machine learning model and everything. But you would have struggled to deploy that anywhere else apart from your local machine, I think, and get that anywhere near a level of confidence and safety around what the thing is doing, where it's hosted, is it safe, um, how is all that kind of back end working, and who is it with, and all those kind of um, those points around um, security and architecture and stuff. I think you would have just accepted what the agent wanted to do, and maybe it would have led you down a rabbit hole, but you wouldn't really have understood what it was doing. So I think these tools are brilliant at getting something up really, really quickly and running it locally. And to get to that kind of prototype stage, maybe you don't have to understand any of that stuff. I suppose the point is the initial idea and the prototype you can build very quickly, and you don't need to know what you're doing, and it's all just running locally or in some provider that they pick for you, then fine. What's been really interesting about this journey, this week and a half long journey, is you really start to figure out when this all kind of not breaks down, but when you have to change modes. And we've talked about this before. I think I wrote a thing about it before called building fast and building slow. That is absolutely 100% true. It's really easy to build something from scratch, from new, when there aren't any constraints. It's completely different when you've got a live system up that's recording telemetry every 5 minutes. You've got a complicated back-end architecture. You've got real users, and then you get to the point where it's like, yeah, we've actually done this wrong. We've architected this wrong. It's not going to scale. So we need to change this now. We need to change this architecture so it behaves in this way. All of a sudden, you're not just accepting the stuff the agent's telling you anymore. You're kind of going, hang on a minute. We haven't thought about this bit, or we haven't thought about this bit. And so I moved from this mode right at the beginning of this experiment, where I was iterating super fast, would bash out multiple features a day, to where I am right now, which is I will spend 2 days planning a feature and making sure it's nailed all the edge cases, and I'm very confident I know what it's talking about, what it's doing, before I hit that go button. When I say days, by the way, what I mean is the little bits of time I get between the meetings or cups of tea, or maybe snatching a few hours in the evening. It's not, this
Yeah.
isn't quite day job territory yet.
Yeah. So what you're saying is, I think because that piece you wrote, building fast, building slow, we talked about it before, was written maybe even a year ago now. It was when everyone was kind of really getting into that idea of AI coding assistants. They were enabling engineers to build test harnesses or scaffold out functions and make suggestions based on the current code base, that kind of thing. But it was very much a coding assistant that was helping an engineer approach their day to day. You're saying you're now applying the same thing to this agentic platform, which is essentially writing all of the code for you.
Yeah, and I don't see that changing. It's really lowered the entry point for most people now. Most people can have an idea. They can use one of these tools to see it on the screen, to interact with it, to do stuff. That's great. And maybe there's some software that you would have bought as an individual before that maybe you because you use it so frequently, or it's a very not very important piece of what you do, you can just get an agent to write that for you now, maybe. But I said back then, and I maintain today, any significantly complex software system uh, is not something you can just let agents run wild on. You really need to understand it. You really need to know what it's doing. It's very, very easy to let these agents break them, and so that's I wouldn't say it's a limitation. It's just a fact of life. They're good at writing code. They're good at understanding systems, but they're not. They're limited in their understanding of the end to end of the system. Sometimes because they have quite small context windows still as well.
Hmm.
I actually can't reason over that much of the system or that much of the code at the same time. So yeah, a systems engineer or a systems architect, or I don't know what you want to call them, but somebody with an awful lot of experience about how cloud services are strung together, how they work, why you should use this one over this one. All those decisions, they still need to be part of the mix, and somebody needs to make those decisions. And actually, that's the really complex bit in software, and that's why it slowed down for me. Is because when you're grappling with, do I use this type of queue or that type of queue, or do I switch to pub sub, or do I stick with polling, or if I do this, can I reduce the scheduling load? And is this gonna increase my database usage to the point where I'm now spending loads more money? All those things you want to think about.
Hmm.
The AI doesn't care. AI doesn't care if you're going to introduce a change, and all of a sudden your database costs are going to triple. So yeah, you do need to be in control.
Yeah, that's where the professionals come in. Okay, okay. But so, okay, I think what you're saying though is you've seen enough now, both in terms of the work that you've done, the work that we're doing internally within our own teams, the work that we started doing for customers around agentic teams and deployments. You've seen enough now that this feels like the direction of travel, and this is actually going to end up being the process, the tooling, the mode of working which goes into business, enterprise, and beyond to build real software. This is the future.
Yeah, and that raises some interesting points, I think. Going back to what I said just now, the planning thing, when you slow down and you do that kind of 2-day planning session, the complaints you're hearing is, oh, well, it all breaks down. You still have to get involved. Yes, you do still have to get involved. And yes, you do still have to think about it. But once you've done all the thinking, it can build the thing in 45 minutes. So that is fundamentally different, because before you would have had to do all the thinking and then you would have had to do all the coding. And the coding is hard because it's not even just coding; it's going off and reading all the details of the library that you're going to use, or the instruction of how to do this, or finding this bit of code to do this, or that's all taken care of for you. So there is still a material gain in efficiency and speed and velocity, and anybody that says there is no gain at all is just wrong. So from that point of view, it is the future, and it is absolutely going to speed up software development. It doesn't take away from the fact that somebody's going to be sitting there scratching their head figuring out what to do, and that's still going to take time. But the time in actually producing the code once you've done that is definitely reduced. There's the second thing I think that was really interesting is the amount of stuff that you can offload, and maybe the amount of stuff that used to be specialist tasks that now needs less specialism. So I think let me frame this in this kind of way. Okay, right. So when you used to write code a long, long time ago, you would write in assembly, okay, which is just one step away from the zeros and ones, and nobody does that today, right? As soon as high level languages came out, and high level languages are computer programming languages that let you write in stuff that looks sort of like a cross between English and maths. So if this condition, then that condition, loop 10 times, do this. When those high level languages came out, the assembly guys were like, oh, they're white shit code. Nobody's ever going to use these for anything serious. What actually happened was the compilers, the thing that took that high level language and turned it into assembly code, just got better and better and better, and they optimized and optimized and optimized, and to the point where they could actually write better and more optimized code than the assembly
Mm.
programmers. And I think basically we're going to go through that again over the next however many years. I don't know how long it's going to take, a year, 2 years, 5 years, but these agentic coding tools are going to be writing the code. And today, there's a real debate. There's people that are right on the bleeding edge, and they're like, you don't need to look at the code. The agents can reason over that high level code better than you can. You don't want to waste all your time making sure the code properly structured and beautiful, such that a human can read it and interpret it, because a human's not going to read it and interpret it. It's the agent that's working on that code base. But that's really going against the grain, right? You're telling engineers that they've got to give up on decades worth of best practice, and just trust that the agent does understand that code, and that's a huge leap.
Mhm.
So that's mainly not happening at the moment, but it is definitely happening in some spheres. Now, let's talk about the spheres that it is happening. So those people they want to move to this point where, just like the high level language versus assembly, they're not worried anymore. They don't want to have to be worried about the actual code that the agent writes. You need to tighten up on certain things, right? You need to make sure that if you can't see the code, you at least need to make sure that it's validated somehow. So you want to be writing lots of tests. You want to be creating lots of conditions under which it must pass this for this performance metric, or it must pass this for this security metric, which you would have had in anyway in standard software development, but this now becomes part of the process. And rather than maybe getting specialists involved to do this, you can codify some of the specialisms in agentic skills. So to give you an example, my little test project that I made, I have a whole bunch of things running overnight now. So I've got a task running that runs performance tests against all the database code, and then when I wake up in the morning, I'll look at my inbox and it'll say, "Oh, this has regressed by 100 milliseconds, maybe consider doing this, this, and this." I've got another thing that's running looking for easy, low-hanging fruit kind of code refactors, like this file's now 3,000 lines of code, we should split it up into these submodules or whatever. And then there's another one that goes through and rewrites all the documentation and keeps that up to date. So there's a lot of stuff that you can just offload. These are all things that used to take significant amounts of time in a traditional development lifecycle.
And a specialist person do it often as well.
Yeah, and this is the conflict at the moment. So I can use a security architect skill, and I can get that skill, which embodies in it all the things that a security architect would look for. I can run it over my code base. It can reason about the back end. It can make suggestions. So in some ways, it's a bit like right now you'd hire in a pen testing company. They'd go and test your code, and then the right report, you'd get that. And then you'd have to implement those changes, and it would go through another round of testing. You get a green tick in the box, and you're good to go. So it's kind of like that, but without all the expense. I'm sure anybody who's in that area now will be alarmed at what I just said. The thing is, it's like the building fast, building slow thing, right? It's going to catch some stuff that you as an engineer wouldn't have caught before because you don't spend your life in that security domain. So it will help. But will it be as good as an actual security architect or pen tester? I don't think so. Will it know where to look across the bounds of your system? I don't think so. Maybe it will do at some point in the future, but I don't think we're there yet. So I think basically I'm saying there's a whole bunch of benefits you can get right out of the box through now employing these kind of automations that run while you're asleep. And give you tasks to follow up with the next day. That's great. But they're not the silver bullet, I don't think.
Yeah. Okay. So this is maturing as we're going along. Yeah. And it's changing so fast. I'm going to say we were talking about things that we wrote and discussed only 12 months ago, and already they're not obsolete, but they've been built upon, they've evolved, and now they're being applied to this new thing. There's definitely a future where architects of various flavors are orchestrating swarms of agents to build out software where previously you would have required a year and 10 people. You now require less time and a whole bunch of agents being orchestrated. That's the direction of travel, and we can see it now. It's now real. We can now see the process that needs to be deployed. We can see that a new software development lifecycle needs to be engaged in upon, a new set of skills, a new set of training. But it's real. We can feel it. We can see it. We know what we can see the end game. We can start to see something that resembles what the end game is going to look like coming together, which is
Yeah,
exciting.
I think so. And the guys at the frontier, they are very much in this world. So I use Codex. Another agentic coding tool is called Claude Code. Claude Code, built by Anthropic, now builds Claude Code. So engineers are using Claude Code to build Claude Code. But Anthropic are currently hiring for 100 developers, people,
Right.
to build Claude Code. And so, all the discourse on X is, oh, well, why are you still hiring for 100 developers to Claude Code and now building Claude Code? And the architect of Claude Code jumped into that debate and he said, well, because we need those guys to run Claude Code, to build Claude Code. We need people that understand what users want, how to turn them into technical language, understand the bounds of the system, understands when things break, understands what's the limits. And it's a weird, because you're kind of talking about this person, which is, they need all the skills that a traditional software architect would have had, but they also need all the skills that a product developer would have had. They need to be these real T-shaped people.
Yeah, interesting. Okay, right. Let's get into the nitty gritty of this. We've talked about where it's going. We talked about why we think this is the relevant end game and direction of travel. We've talked about why we've started to deploy this with our customers. Let's talk about what you've learned being on the ground in the trenches as a rusty chief architect orchestrator with these bots. So you quite articulate quite well articulated. There's an irony in me falling over the word there. You quite well put that together in your post. You put 6 lessons from the trenches of using Codex. We're going to go through them one at a time. I'm going to read you the lesson, and you are going to explain what on earth you meant and where it came from. So lesson 1: repo must be self-describing.
I'm just aware of the audience here, so I need to unpack that. A repository is the word we give for something that contains all the code for an application. And it's like, I suppose, a folder on your desktop that's got loads and loads of files in it. So these are all the files that make up the system, and they have the actual code in. That's all you need if you're a human, maybe. If you're an agent, then you don't necessarily want to go off to a separate wiki or tap your colleague on the shoulder and ask them about something or how something works, or go through a whole bunch of project onboarding documents that live in a different system to understand what the hell's going on. Why does this piece of software exist? What does it do? How is it laid out? What all these files and conventions? If we're talking about a particular feature, then what are the things I need to know? The gotchas. Can't go and talk to the developer that built this feature, so I need to know like what where the pain points are, and if I'm going to change it, then what do I need to be aware of? So one of the patterns that's emerged fairly recently, OpenAI did a big article on it only a couple of weeks ago, is this kind of self-describing repositories. Where the agent's basically just told, look, if you want to find out anything about anything, look in the docs folder inside this repository. And in there, that's split up into a whole bunch of sub things where you can understand why certain decisions were made. You can understand what standards we're trying to adhere to when we're reasoning or about this project or writing the code for this project. Maybe you can understand lessons that we've learned along the way. Maybe you can go in there and look at the audits that we've done. So you can refresh your memory on the performance metrics and the security architecture and all that kind of stuff. So that tends to work really well when you've got an agentic coding tool, which every time you're starting a new feature, it's essentially got a blank brain. So it needs to load its brain with all the stuff that's relevant to everything you're about to do. And it starts by looking at this file called agents.md. MD is a markdown file. And in the early days. Can you say that? It was only like 12 months ago. I suppose the agents MD file would get massive, and over time it would just have all this learning and it would become a mess. But now the idea is that you have this kind of describing repository with this sort of docs folder or something, and the agent file knows where to look in there for various things. So it can be quite selective about what it sticks back into its brain before you embark upon this next round of feature development.
Right. So this is more than the code is the design. It's not that mantra. But is it it sounds a bit like you're saying just put the project wiki in the repository.
I mean, it's a bit like that. Yeah, it basically is a bit like that.
Yeah, yeah. Okay. Cool. So yeah, that makes sense. So lesson 2, spec driven development is a superpower.
Yes. So, we've already talked about how I approach this, which was we do a lot of planning. We're in the planning phase, and then we go into the implementation. Perhaps what I didn't make quite clear is after that planning phase, where we've really understood the feature and what we're trying to do and what we're trying to build and how we're trying to build it, the first thing it does in my little side project is create a spec file, a spec.md, and a design file, design.md. And that gets saved in this docs folder, in this self-describing repository as this is the feature, this is what we agreed. And it's really comprehensive because now you can generate documentation for free because the agent is generating the documentation. It carries way more detail potentially than you would have traditionally done in a sprint planning meeting or an iteration or whatever.
This is
Because
yeah, isn't it? That the agent is writing the docs, so is writing the specification.
yeah,
Is you're in the planning phase, you're discussing with the agent, you're articulating what you want a feature to be, and then the agent is updating the doc. Then maybe some code is written, and the docs are updating. You're not writing the docs, or the agent is doing all that work.
no, well, it's just like you would use ChatGPT or Claude today to summarize your meeting notes, right? You can pull in all this context. This was the transcript from the call. This was what Rob said about it. This is the needs that are coming from the board, and then you can feed all that in and go, right, write me the brief, and it takes all of that context and like produces a really nicely formatted, detailed brief. It's the same thing in planning mode. So it's taken in all your thoughts and all your discussions, right? It's got that. That's one input, but it's also got the code itself, the existing code. So that's another input.
Mhm.
And then it's also got the stuff you've already put in this wiki or this, self-describing repository. So it understands, what you should do and what you shouldn't do. And if you're doing this kind of feature, then you need to consider these kinds. So it takes all that into the context and then writes the spec. So I think that the quality of the documentation, the quality of the specification that you get out is superior in many cases to what you would have had out the software development process in the past, because you've just got way more context and you haven't got a lazy human writing it. You've got something very detailed. And that level of detail benefits both the human and the agent because it bounds what the coding agent then goes off and does, and it's working to a spec. So that's fantastic for actually the developer agent workflow because you can use that as a baseline. We've agreed this thing, but work together, and we've agreed this thing. Now you're going to go off and implement it. Great, but it's great for also understanding and evolving of the product over time. So now my thermostat app has got, I don't know, 20, 30 different features, and they're all in that repository. They're all described. They've all got a spec. The agent now can go back through that, look over that and go, okay, I understand what this application does and how it works and why we made the decisions that we made along the way. So you've got this huge amount of valuable information. And because it's an agent, you can say, right, take all this information and turn it into a specification document. I want to give, a capability report to my customer or my user. I want to describe for my marketing website what this does and why it does it and why it's great. You can use those kind of spec documents as the basis for any derivative work going forward, which I think is fantastic. Not to say you couldn't have done that with various things we were doing in the past, but it's easier and it's more detailed and it's live. I mean, keeping a living specification document in the old world actually up to date is really hard. It requires a lot of human discipline. Doing it in this world is a lot easier.
Yeah. So is it, I mean, just reflecting on some of the things you said earlier as well, is this where the work is in this new world? Is it working on refining, honing this specification? Is that where all the time is being spent by the human architect, orchestrators?
I think it's one of the main areas of time, yes. And I think the other, so it's the before and after actually is where all the time is. So the before is the spec, the agent does the code. The after is all the discipline I think you still need as a human to tidy up all the loose ends. Okay, now this feature's been implemented, ship it. No, don't ship it. Do all the can we validate that the tests are all passing? Can we just make sure we've covered off all the edge cases? Can we do the mop up, right? Can we do the post mortem? What lessons did we learn along the way? Because these things make mistakes, right? I was doing something actually just yesterday and it completely messed up the production environment. So this is a big warning, right? It fixed itself, but then it's like, okay, well, what lesson did we learn? Because you thought you could do this, and then it obviously failed, and you found out you had to do something else. So write that lesson, keep that in the repository. So the next time we have to do a deployment involving Google Cloud tasks, you won't make the same mistake. So I think that mop up is really, really important. So the discipline, I think, is a discipline sandwich.
Right. That brings us nicely on to lesson 3, I think. Discipline matters because chaos is contagious.
Yeah. Okay. So it does basically, it's very similar to what I was just talking about, except with a bit more nuance. So you should define a process which works, and for me and for what I believe this is going, that is this kind of discipline sandwich. You have the specification phase, you have the implementation phase, and then you have the mop up phase, for want of a better word. The issue is that it's very easy to break out of that because you go off down a rabbit go down a rabbit hole. So you're working on a particular feature. You've got your process up and running. So you're creating a new task. You've got however many tokens left in your context window. You're having a discussion. The context window is gradually filling up. If that context window gets too big, bad things start happening. So you want to try and develop your feature within that context window. Then you go to the testing phase, and especially if it involves some UI stuff, you realize it's not quite working as it should because the unit tests don't really catch that. So you go back and you start making all these tweaks, but then you're muddying. It's quite easy then to kind of get distracted and go off and oh, I made that level change there, so I'm going to make it in this thing down here as well, which has nothing to do with the feature you were just working on.
Right.
So quite quickly, your thread that's very focused on this particular task can drift into a whole bunch of other areas, and all of a sudden you've messed up your process because this feature that you're working on is no longer just this feature anymore. It's a mismatch of that plus some other stuff you were doing.
Yeah, I've definitely done that because your brain goes off all kinds of random places, doesn't it? When you think, oh, I just thought of this, I just thought of that. So, what's the strategy for that? When you're working on one feature and it sparked an idea, a little fix somewhere or a little tweak somewhere else. How do you capture that while maintaining the discipline?
Yeah, so well, I didn't. Sometimes I just just typed in and made a mess. But I think the answer I've come to in the last sort of I guess only a few days, just walk away from the screen. Just like it's too, especially when you're working on a plan at the beginning and you're like, I still don't think, I'm still worried that that's going to hammer the database, or I'm still worried that this change is going to, it was going to do that, it was going to do that thing, but we didn't think about how it would affect that thing. And there's something very human about just needing time to let go and then to think broader. And if you rush a feature, this is a weird thing about it. These things can work so fast, but if you let them work that fast, you're going to make more mistakes. And that's a real paradox, I think.
But it's almost like a self-fulfilling loop, isn't it? Because the speed at which these things get developed, you see, oh, I could just do this. I could just do one more. It's what was that classic computer game? Civilization. Civilization had that thing, didn't it? One more turn. Just one more turn. And it's once you get going and you get into a pattern and a rhythm, it's very easy just to do, just do this one little thing.
I wonder, though, I genuinely wonder how much time will be wasted because this thing is so fast. Because it's so fast, you want to respond to it instantly, and you spend all your time fixing things that you're introducing because you haven't thought about them properly in the first place. And
Yeah.
it's weird that actually moving slower could mean that you get further
And this is why
faster.
a new agentic is so important. The process behind the tooling here, which is going to, govern and enable in equal measure the orchestrator to produce great outputs. That process is vital and it can't be skipped. It needs to be honed and nailed.
Yeah, I do. I think there's a real discipline around how you should work and how you should use the available features that you now have, like automation, self-describing repositories, specification phases, mop-up phases. You almost want to enforce something where you can't just write a spec and then hit go. You like
Yeah.
sometimes you just need a bit of breathing space so you can remember the things you hadn't remembered when you were working on that spec in the first place. So if you don't step away from the computer, you're in danger of rushing in and doing something when you haven't fully thought about it. And I do think that's really paradoxical because it feels completely wrong to put the brakes on.
Because all the friction's been removed. I mean, in the old world, you would have been thinking as you were coding, right? And then you would have realized halfway through writing a function that, oh, actually, I've not thought about this, or I need to think about that. And so you'd go back and you've only lost a couple of lines of code or whatever.
Yeah.
But now this gone off and built a feature before you've realized what it's done.
And I mean, it's different for me, right? Because I'm snatching a few minutes here and there. But if you're doing this every day, then I guess it would be very, very tempting to spend, okay, well, I spent, I don't know, half a day planning this feature. I've got a 2-hour meeting after lunch. But if I get this thing going, then I can come back and it'll be done the next morning. Or I don't know. There's always this. It feels like there could be this real demand to just get going, set the agent off. But actually, it doesn't. It would be better to spend some extra time just making sure that before you press go, you really have got that understanding and that spec in place. One thing I found actually that's a bit of a tangent, but that's been brilliant for me as a ex-developer is it constantly spits out stuff in these specifications that I have no idea what it's talking about. And when it's a very complex feature, so I don't want to hit go unless I understand what the hell it's talking about because it could break stuff. So I found myself spending a lot of time interrogating it after it written the spec to find out what it was talking about. This I understand this service, but it wants to use this service, and I've never heard of that before. So how does that work? And should I actually use that one as opposed to that one? And what are the benefits? And is it going to cause a storm of events that I'm going to regret later? So bizarrely, I mean, I'm very rusty, so maybe it's different if you're a pro, but I find it actually makes you more attentive to the systems and the libraries which you're going to then go off and use.
Yeah. Okay. Cool. All right. Lesson 4: collaboration handshakes make agents fun.
Yeah, I mean, this was a silly one, really, but you're seeing it all over the place now, actually, with developers who want to work in a certain way. So every developer loves their own little flavor. They install their own tools and they've got all their own command line hacks and all this kind of stuff. And this is the agentic equivalent. So there were little conventions that I found it's easier if you stick that in the agents.md file, then you can basically instruct it how to behave or kind of when you want to work in a certain mode. Codex has got a planning mode, and most of these things do. So I didn't have to say, right, I start a new thread and I want to plan a feature, then this is how we should behave. I didn't have to do that because it's got this thing in. So, but I would have said stuff like, don't make any code changes, don't push to live. This is conversational only, that kind of thing. But there was a time when we'd worked on a feature and I wanted to work on the UI because I've always loved design and I'm very picky when it comes to UI, so I wanted this thing to look good. I'm not happy if this button's 2 pixels away from where it should be and that kind of thing. So, but by default, in its normal mode of operation, it wants every time you make a little change, it wants to be very thorough. It wants to do everything. So I'm rerunning all the tests. I'm testing the performance. I'm and actually, you don't want that. You just want to quickly see if this button's moved in much further up the screen or not. And actually, what I probably should do is just edit the CSS because it would be quicker. but now I've got this like bot that can do it for me, it's quite easy not to realize that you can get stuck into the code. So yeah, we came up with this convention which was like rapid mode, and I would say something like, right, rapid mode on, and that would tell it to not do all this kind of linting and testing and all that kind of stuff, and then I could turn it off again. So it changed its behavior based on what I was trying to do and what mode we were working in.
Yeah. Okay. Makes sense. Great. Lesson 5: automate everything. Let the agent work while you sleep. I think you touched on this already.
Yeah, yeah. So I do think that's a freebie, right? You might as well. The extent to which it's useful or not is very variable, but you might as well schedule overnight performance tests and overnight low hanging fruit code reviews in terms or code refactoring reviews. You might as well see if any recent changes you've introduced widen the security or threat surface, that kind of thing, because you can, and you don't have to think about it. If you can codify the thought
Mm.
process and put that in a scheduled task, and that can happen overnight.
Yeah, it leans. I mean, again, it leans into the discipline one, doesn't it? I mean, you don't want to do the equivalent of releasing something to live on a Friday afternoon, for example, just because you can. You need that discipline in place to say, no, the process says I'm not going to rush this feature through and hit go before my 2-hour meeting just because I want to get it done. I'm going to put a pause in. I'm going to stop and think. So building building that process around the power it's going to be vital, isn't it? Because the temptation is just going to be to rush it through.
I'm
Just like,
actually I'm very worried about the discourse I read. It sounds awesome, right? But it's also incredibly worrying. There's some people saying, "Oh, I've got 8, 10 Claude terminals up, and we're working on all these different features at all these different times." It's like, that's fine, but I don't know what you're building. Are you building a fun throwaway project, or are you building the next aircraft control system? Because you just want some care and attention. You want to know that that's there, and I'm worried that we're stretching our human. We're trying to demand too much of ourselves as humans just because we have this alien that can spit stuff out at huge volume.
yeah, yeah. Okay. Lesson 6, last but not least: autonomy is power, but boundaries are essential.
Autonomy is power, boundaries are essential. Don't know what I meant by that. What do I mean
Apparently,
by that?
full access to your machine early on.
Oh, yes.
Oh, now that sounds like a terrible idea. Just putting that
Yeah.
out there.
That should have been lesson number 1, not lesson
It
number
should have
6.
been, really. By
Um,
this stage, everyone is completely screwed.
yeah. Yeah, so this was actually the first lesson I learned. Um, so, ah, so when you start, especially with Codex on the Mac, it's sort of locked down. It puts it in what they call a sandbox mode, which means it can't just go and do stuff on your machine. And that's quite frustrating because if you need to install a library to get something working, then it can't do it, or it kind of does it, but the environment in which it does it in, it throws it away after, so it's not really on your machine, um, which which means you're stuck doing all the grunt work that you don't want to do. Right, the agent can do all this stuff, but it's in a sandbox, so it's all useless. So I was like, no, I've read all the stuff. I think I can enable full access. Let's go, and I do use full access mode now a lot of the time, and it's brilliant. However, I I started a new project. This wasn't my side project. This was something else which I didn't carry on with. Um, and I hadn't put the version control in yet. So this was when you start a new project, you normally run this kind of thing called Git, and that makes sure that any changes you make to your files going forward, if you want to undo it, you can undo it easily. And if you want to commit that change for the future, then you can do that, and it keeps a log and all this stuff. So I hadn't initialized that. And if you're a software developer, you do that, right? Everyone knows that you do that. And I think Codex was expecting that that should be there. So I was talking to it about something, and I said, "Right, we're gonna plan this thing now." And I don't know why. I don't even know what I said, but it got the wrong end of the stick, and it was like, "Oh, he's mentioned a plan. We need to go and find the plan. I've looked in this folder, but it hasn't been initialized with the plan, so maybe it's in a different folder. I'll have a look at some of these other folders." I'm searching through all the folders in develop. Oh, I haven't found anything useful in there. I'll go and see if I can find it on his desktop. So it went off, and then it started popping up all these like warnings saying, off of the operating system saying, "Oh, Codex is asking for permission to access your desktop." I was like, "Well, no, don't do that." And then it was like, "Codex is asking permission to access Apple Music." I was like, "Why is it trying to access Apple Music? Where do you think this file's going to be?" So it's like, "Stop. We're not going any further. Let's start again." So yeah, full access mode is great, but it certainly likes certain things to be in place and expects to work in a certain way. So be careful.
Yeah, maybe when you're experimenting with this thing, have a first time round, have a clean machine that's not connected to all of your critical systems.
I wish actually I'd asked it why it thought it needed access to Apple Music, but I didn't. I just stopped it and killed it.
Well, the next time. Brilliant. Well, I mean, that's incredible. And what's really interesting about that is obviously you've come at it from an angle of knowing enough to get you going and falling into a lot of those gotchas. But obviously we're building this stuff out right now in terms of process, and obviously those conversations are live. So really fascinating to how we can build that into what's going to happen going forward. Overall, it seems like quite a lot has changed, but quite a lot hasn't. All of the naysayers or the people saying software engineering is dead, as a discipline, this is disappearing, as a professional service, it's not required anymore. People are not going to be hiring technical people, all that kind of stuff. It feels premature, but there's definitely a sense that something has changed. Like
Mm.
that something has changed. Have you managed to put your finger on it yet?
I haven't found a way to say it as succinctly as I want to say it. I don't think. The job has changed. The discipline hasn't. The discipline has actually become more prescient than it used to be. What everybody seems to be finding is all the stuff we've talked about for years, as this is the way you should develop software, is even more true
Mm.
in this new world of agents, where the code itself is being written and developed very quickly. So all the guards you put around it, the specifications up front, the testing, they're even more essential now, and what makes that exciting and good is that those things used to be really laborious and so prone to human error because humans didn't want to do that bit. That wasn't the fun bit. The fun bit was writing the code and seeing the thing working. These specs now get written collaboratively. Okay, it takes maybe a few rounds and a bit of back and forward, and maybe that is still the biggest amount of effort, but it's not the same amount of effort as it used to be because to write that thing up, or and you can suck in context and explore it a lot more quickly. So I think the discipline is there and it will evolve, and you almost need to double down on that in a way. I still don't know, like I said, how we're going to tackle this issue of it's too easy to do stuff too fast now.
Mm.
I don't think I don't think there's an answer for that yet. And I don't think we've really worked out the bounds around automation and what can you automate versus what can't you. Where do you put the governance? So you got the engineering governance because you got the architect or the engineer who's controlling the agent. But there's a level above that, isn't there? There's a kind of bench of other stuff that you need to make sure you've got some human input on, especially when you're developing significant, complex, mission critical software systems. So yeah, the job is changing. The discipline is more important than ever.
Yeah, it feels like you've described a world really where those who are lazy, those who are ill-disciplined, those who have been more prone or more willing to cut corners in processes that already exist, but people either pay lip service to or are inclined to ignore if they can get away with it. They're just going to get found out quicker because they're going to create chaos much more quickly. Whereas the mechanisms that were maybe in place before, whether that was code reviews or code coverage, all that kind of stuff, that doesn't exist in this new world yet, or it's emerging in this new world yet. So we need a version of that. Otherwise, chaos is just gonna reign.
Spider-Man said it best, didn't he? With great power comes great responsibility.
Well, so hopefully that's been really useful. 6 lessons from the trenches from our very own CTO and the self-declared rusty architect. What's coming next, I think we've hinted at already, is that we believe now that the agentic SDLC needs to come to the fore, and so we're going to be pushing really hard. We're already working with customers on this right now. So we firmly believe this is the future. Lots more information is going to come out about this very, very soon. Love to hear as well anyone else that's having their own experiences in this space, because I know we're not the only ones experimenting. We're not the only ones moving this agenda forward. So yeah, do let us know what you think and where it's going. But I
Awesome.
think for now, I think that's the pod.